Hello, everyone. Now, this question might pose a little challenge for some people, especially because it's deal with measurements. Now, you will find other videos on YouTube that perhaps cover this particular question, but what I'll do different is to use some geometrical solids to help us to understand this better. All right. So, as you can see, here we have a what? What is this? If it's a rectangular prism, that's correct. What shape is this? Well, if you say that this is a triangular base prism, then that's correct. What shape is this? If we say a circular base prism, highly unlikely you say that, but that'll be correct. But another name for it is a cylinder. Okay, so now let's go back to this. So what we have actually is a rectangular base prism on top of a semicircular cylindrical base. I may add prism at the end. Yes, this is also a prism. Now what is a prism exactly? Now let me just give you the definition for a prism, and you can read it with me. One moment. So what is it saying here? A prism is. It's saying a prism. It is a polyhedron that has a uniform cross section along one of its lengths. And if you look at this, I showed you one of this, right? The triangular base prism. This is a triangle. And no matter where you cut, if you cut this side here, all the way through the shape, you will still get this triangle all the way through to the other end. And this end and the other end are uniform. They are basically congruent. In other words, they are matching ends. This end will match exactly onto this other end. Once we cut along this length, every face will actually have this same shape all the way through. So if you want to find the volume, for instance, of this prism, it says here that the volume of a prism is therefore easily calculated by multiplying what? The area of the uniform cross-section by its length, by the length. So this is the area of the uniform cross-section. This is the only shape where there are face that you can actually cut all the way through and get matching faces all the way through to the end. Okay, so this will be our what? The area of the uniform cross-section. Uniform mean same, congruent all the way through. So once you find the area for this side, you multiply by the distance between this side and that side. So in other words, let me show you exactly what I'm saying here. Now let's suppose the area of this triangle is about 20 centimeters squared. And the distance from here, this point here, to this point here, let's say that distance is 15 centimeters. Remember, this is talking about length, so centimeters. Area, square units. So if you want to find the volume, you'll multiply what? The area of the cross-sectional, that is uniform all the way through, which is going to be this side here, the area of the triangle, which is 20 centimeters squared. And then we do what with it? We'll multiply by the distance between both uniform cross-section. That's 15 centimeters. Okay, and so the volume will be equal to what? Centimeters squared times centimeters will increase in one power, so it's going to be centimeters cubed. Of course, volume is in cubic units. And 20 times 15, that would be 300. 15 times 2 is 30, that is 0 to end, so yes, that's the volume. So that's how you find the volume, basically, of a prism. The area of the uniform cross-section times the distance between both uniform. So let's say I decide to, look at this circle, the top of the cylinder. I'm basically going to pass it through the center. Let's go again. Right. So assuming that we have the center, right, of this shape being here, right, somewhere here, that'll be the center. And this line passes through the center. That's called our what? Diameter, correct? Good. And imagine I should use a saw and cut along this line and cut it right down to the other end of the shape. what we end up with is something precisely like what we have underneath here. Isn't that so? So this is the half of the cylinder, this shape here. So this is basically a semicircle because I would have cut off on top, going right through this side, this length, from this circle to this circle, and so we end up with two semicircles. All right, so that is helpful to see or visualize. Once I cut along this line here, going all the way down through it. Okay, and so remember that this length here is called a diameter. So if I want to find the radius, then we have to look at this length from here, from this point to this point here, that will be the radius length. So from this point to this point here, here to here, that's going to be the radius. Remember, the full thing going from this end through the center to this end here will be what? The diameter. It must touch the other end, by the way. Okay, and then from the center, this end, that's our radius length. That's going to be the radius. So basically, the radius is equal to the diameter, length of the diameter, divided by 2. Because we can get 2 radii in one diameter. So if we know the diameter, the distance here from one end to the next, through the center to the other end, which is the diameter length, then it's easy for us to find the radius. And if you look at this drawing here, so here we have this cylinder, our semicircular cylinder, because it's half of the cylinder. This would have been what? This would have been the, look at this, this would have been the diameter. I'm sure if you think about it coming all the way around here, like that, you get the entire circle, right? And coming all the way through here, we've gotten the entire circle, going all the way around the cylinder, cutting across there. Okay, good. And so this will be the diameter. And so if the diameter here is 4 centimeters, right? Remember, we're told that this length, the same as this length, because it's a rectangle, obviously. And this part is part of the rectangle, is also part of the semicircle. So this diameter is 4 centimeters. Thinking of it as a diameter when we think about this semicircle here. Okay? And so the radius will be half of it, half of that. So the radius is equal to 4 centimeters, which is the diameter, divided by 2, you get 2 centimeters. Hope that is clear. So the same thing that we have here. If this is 4 centimeters all the way through here, then this is going to be 4 centimeters, which is the diameter, divided by 2, which gives us 2 centimeters from the center to the end. And hopefully that's helpful for you to understand and visualize. Remember, we're cutting along here, and we're cutting all the way through, going straight down. Okay? So this is also a prism. Remember, we cut along here, going right through, uniformly, going right through. Every face will be a circle all the way through to the opposite face. And we say it's uniformal. You got uniform, everything looks the same, everything is congruent, everything is matching. Okay, good. So let's now deal with the question that we have at hand. Now, how would you calculate the total surface area of this cuboid, or should I say the rectangular prism? Well, you can find the area of this face. Now, to find the area, multiply what? The length by the width. The length is the longest side of a rectangle. This will be the length, and the shorter side with the width. Multiply the length by the width, and this gives you the area that we have here. Now remember, this face is same as the one on the opposite end, the congruent, same shape, same size. So once you know the area for this side, you can multiply by 2 to get the total for this side and this side. Once you know the area for this side, or this face I should say, you multiply by 2 because you have the same congruent face on the opposite side as well. So once you find it for this, you don't need to go and calculate for this again. So this found, multiply by 2 for this and this. Once you find the area for this side, multiply by 2 as well, because it covers for this side and this side. And the same thing, when you find the area for the top face, you also find the area for the bottom face. So you can actually multiply by 2. But the thing about the example, the exam question that we're looking at, this face is hidden. So that would be part of the surface because it's actually on top of the semicircular cylindrical base prism. So this side will not be counted as part of the surface. So all we'll be doing is finding this face, this end, and this end. Find the area for those two sides. Find the area for this and this side, but not the one underneath, since it's on top of the half cylinder. Okay. So you cut this along here and take it off. And you put the prism on top of it. Okay, and it covers top of it. So let's go back to this. So therefore, now we can start. I know it's pretty long, but I want you to understand and visualize it. So the surface area of the cylinder, as we told it, of any cylinder, like this cylinder here, right? That I just showed you. The surface area of this. The total surface area of a cylinder. So let's say we have a circle. All right. So let's look at it. We have a circle. And we want to find the area. All right, so we'll pass this. That's a diameter. That's the diameter right there. Okay, and then so we have the center. So if you want to find the area of this circle, the area of a circle is given as pi r squared. Pi being 22 over 7, or better yet, let's use 3.142 on and on, but we just use 3 decimal places. Or 2, if we say 3.142. Sometimes they tell you sometimes they tell you actually 22 over 7. That's a value. Pi is a number. And the radius is half of the diameter. So this diameter, find half of it, that's the radius. We have a radius length here, from there to there. We also have another radius length here, from there to there, right? Okay, good. So, so let's go. The area of a circle is pi r squared. And remember, we actually have two circles, this end and the other end here. So we actually have what? Let's try to create a formula. Let's try to create the same formula that they actually have there. We want to figure out how did they get that formula that they have there. So we have two circles. So therefore, we can say it's going to be 2 times what? This formula here. Pi r squared is only for 1. So it's going to be 2 pi r squared. Right? Just for the circle alone. So now we need the area for this curved surface here. Now that might be a little more difficult or challenging to explain. So here's what I'll do. Imagine that I have this shape here, right? I'm going to turn it into a circle. It's a little hard to do though. Turn this into a circle, right? Imagine this were a circle, right? All the way through, right? This circle here on top here, this circle on top here, right? We basically know the distance from here going right around. The distance around a circle, like this distance of going right around, it's called the circumference, right? Circumference, and the length of the circumference is given as 2 pi r. If I want to find the distance, let's say from this point going right around back to this point, it's 2 times pi times r. Now just imagine, so this basically here, right around here, going right around is 2 pi r, right? 2 pi r. And so when I open it like that, just imagine what we have there is a square, aren't it? So imagine we have a circle created, like a curved surface area going right around as a circle. And when I open it, we actually get a rectangle. This top part here, so let me just show that quickly. It's going to be a little better than what we actually have there, right? This top part here, is actually the same circle that we had originally, right? So this top part here, when curved, when folded around, is a circle, right? And it's actually what? 2 pi r. So this length here is 2 pi r. And this length here is what? This length here is what? The height. Going from here from this to this is actually the height. So if I want to find the area of the curved region, remember this was actually curved, right? And this was actually curved. This was actually curved like this. And this has got to be the circle. And the circle here is the circumference, which is 2 pi r. Distance all the way around this, the distance around is 2 pi r. And remember, this is a cylinder, right? We're just pretending that this is a cylinder. When you look at this, this will be what? The height of the cylinder. From the circle, from this end to this end is the height of the cylinder. Again, same thing that we have here. This is the, just as if I put it like this. Okay, cover it right around, right? Probably this is better, right? So we have the curved surface going right around here. This is 2 pi r, distance around it. This is the length. So from this end going right around is 2 pi r. When I open it, right, I get basically what? A rectangle. But I don't forget that the top of it, the length of it, all the way around is really a length called 2 pi r, also known as the circumference length. So I put it here as what? As 2 pi r, right here. Okay, good. So you understand how 2 pi r came about? Distance around the circle. But what also you need to bear in mind is that this length, from the top of this circle to the bottom of this circular end, right? Both ends, remember, both ends are circular, right? This end and this end as well. So this distance is what we would call the height of the cylinder. So when I open it, I get a rectangle. This is still the height of the cylinder. So the area basically is given as what? Notice that it forms a rectangle now. So it's actually 2 pi r multiplied by, remember, to find the area of a rectangle, what's the area of a rectangle? The area of a rectangle is given as what? As what? Length. Let's do that over again. It's given as length by width. So we're talking about this length here times this width here. Right? Length times width is the area for a rectangle. So this is my length, or I can call it the height in this case. I'll multiply it by the width, which is in this case is 2 pi r. And so the area of the curved surface area of the cylinder is 2 pi r h. Okay, so the total surface area for a cylinder is the what? The area of the circular part, which is what? Pi r squared. The area for this circle, the area for this region is pi r squared. But because we have two of them, we multiply by 2. Once we find the area for this, we double it, multiply by 2 to get the area for this plus this. And so multiplying by 2, multiplying pi r squared, which is the area for one circle, by 2, we get the total for both circles. And the curved surface area, as I explained, its area is found by doing what? Recognizing that it's basically what? If there's a curved surface all the way around, when we open it, we get what? A rectangle. And the top was really distance of what? Distance of what? 2 pi r. Right? Is what we're showing here. And this is going to be what? The height. So this side of the rectangle is this side is the what? The height, and this side here is the 2 pi r. I'm finding the area of a rectangle is this length by this length, so it's 2 pi r h. And so when I add the curved surface area, with its area being 2 pi r h, we get the total surface area of a cylinder. 2 pi r squared plus 2 pi r h. Now let's look at what they're showing us here and see if the same thing we have. 2 pi r squared, as we can see here, 2 pi r squared plus 2 pi r h. Exactly what we came up with. 2 pi r squared plus 2 pi r h. So I hope that was helpful. Okay, so now let's put this formula into perspective now. Remember, we're only looking at this region here, outside, going right underneath. All right, and this face here as well too, and this side as well. coming on and looking at this outer region going all the way around. So right, so looking at this curve going right around back up to here, right? Looking at just the outer part. Just the outer part. Okay. So all we need to do, we're not looking at the top part here. We're not looking at this top because this is covered, this is hidden. So if we find the total surface area of the cylinder and then cut it in half, like find half of it or divide by 2, then we have the outer part here covered. So let's do that now. So area of semi-circular prism, or semicircular base, I should say. It's a semicircular base prism, but let's call it a semicircular. Right, area of semicircular base is going to be half of the area of the total cylinder. We'll cut it in half, so we're finding half of it. So it's going to be half of the 2 pi r squared plus 2 pi r h. Okay, so this will give us half of 2 is 1, so we end up with pi r squared plus half of 2 again is 1, so end up with pi r h. Now if we were to factor out the common factors, we end up with pi, this and this and this. The r is also common, which was the one with the lowest power. So we're left with an r here plus h. That makes sense? So pi r times r will be pi r squared. Look at it. And pi r times h will be pi r h. Okay, now this should be understandable if you do factorization, so that's a good way to revise that. And we know pi is what? 3.142? Okay, or we're going to leave it at 3.4. They didn't tell us what to use. I'll just use pi in my calculator, punch pi in my calculator. I'm going to multiply pi by r, and r is 2 centimeters, right? And that's what we said. The diameter was 4, r is 4, and we divide by 2 to get 2. The r again is 2, and the height is what? 12. Okay, so again, remember this would have been a circle. We're going to carry this up. Right, that would be a circle. And this will be the diameter passing through. The entire thing is 4 centimeters, as you can see the width. Here's 4 centimeters, that's the diameter. And half of it would be the radius of which 2 centimeters on both sides. So the radius is 2 centimeters. Now, from one end of a cylinder, right? Again, let's mention that we had this situation here. Right? As you can see, that's basically it's going all the way around here. Right? That's a cylinder. From one circular end to the other circular end is what we call the height of the cylinder, or distance, which is 12 centimeters. So from here to here is 12 centimeters. That's the height or length of a cylinder, 12 centimeters. And the radius, we say, is 2. Alright, so this is going to give us, put that in your calculator and see what you get. So let's put that in our calculators. Now, before we even do that, let's multiply this by 2. We get 6.28 times 14. So it's 6.28 times 14. So that's going to give us 87.92. So basically this is 87.92 square centimeters. That's the area of the circular base, a semicircular base. Now we need to find the area of what? We need to also find the area of the cuboid. That's which is on top. So let's find the area of the cuboid. Now to find the area of the cuboid, which is what we call the rectangular base prism, we need to recognize again that that this face here is the same as this face here. So let's find the area of that. These two faces. They're identical, right? Congruent, matching, same size, same shape. The length here is 4 centimeters. And we'll get it from this. This is 4 centimeters. So that means this is 4, because opposite sides for rectangular, opposite sides of or opposite faces for cuboid are congruent, same. This is 4 centimeters. This is 4. So we're gonna go length by width. But it's a square, so just multiply two adjacent side. 4 times 4. Okay, and that will be what? 4, 4, 16. So the area there is 16. Let's call this A. Let's call this face A. So this is going to be face A, and area of A is going to be 4 fours. That's going to be 16 square centimeters. Remember, we have this also. This is my matching, so we're going to basically add this as well to it. This is also the same 16 centimeters squared, right? So that's basically 16 centimeters squared times 2, or double, 16 plus 16, whichever you choose. That will be 32 square centimeters. Okay, so what about, so let's call that A. Plus, let's call this side over here now B. Alright, so let me just take this off. Clarity. Alright, so now let's call this face here, this side here, or face, better term. Let's call this face, let's call that face B. Alright, now on the opposite side to this face, we also have a similar, well, congruent face. So both faces, right, on opposite sides are the same in area. So B, let's work out B. Now this is a rectangle, obviously. So this length here is 12. That length there is 12. And the height here can be found by looking at the opposite height, which is our length, which is 4 centimeters. This is 4. So we're going 12 centimeters by 4 centimeters. Length by width. That's 12 times 4. So the area for B, right, the area for B is equal to 12 times 4, which will give us 48. And of course, we want to multiply that by 2, get 96. Why multiply by 2? Because we have matching faces. The opposite faces are the same. Because you have B in front, you're going to have B behind here as well. So B, right, so A is 32, B is 96. What about the top? The top. Just going to take these off so we don't get confused. Alright, so we're going to find the area on top here. So this area of this face here. Again, this is a rectangle, correct? This length is 12 and this length is 4. So for C, the area is 12 times 4 as well. And 12 4 is 48. And since, well, do we need to double? Do we need to double? The top is 48 square centimeters. What about underneath here? Do we use that? The face is opposite? Well, if we didn't have this semicircular cylinder underneath, then we would use under here as well. But the problem with that underneath there is that it's covered, so it's not a surface. It's no longer a surface. It's covered. It's not part of the outer portion or area or region of the solid. So we're only looking at what's outside that we can touch. If we were to look at this solid and try to touch, the only place we touch is on top, this side, and the curved area, and outside here, same outside there, and behind as well, but not within the solid. So that's why we're going to just look at C on top alone, and the area is 12 by 4, which is 48, so plus C, and that's 48. So when you add 32 to 96 and 48, what do you get for the surface area? Surface area of the cuboid. That portion of it that we can actually touch. 32, I should say. 32 to 96 to 48. Again, that gave us 176. And again, so if we do in centimeters, it's square centimeters. So that's 176 square centimeters. So the area of the cuboid, all right, the outer part, the outer portion, is equal to 176 centimeters squared. And when we add them together now, right, so the total surface area, cuboid plus the semicircular prism, base prism, is 87.92 plus 176, and that will give us what? 176 plus 87.92, and that will give us 263.92 square centimeters. All right, now remember, for those persons who wonder, what couldn't we ever use this alone that they gave us? Could we ever use this and then find half of it or divide by 2? Yeah, that's why half is here. If we had done that, it would have been what? 2 times 3.14 or pi. 3.14, let's use 3.14. Times the radius squared, right? Plus 2 times pi, which is 3.14. Multiplied by, okay, this part is not showing, so I'm going to put the multiplication below here. Multiply by, so 2 times 3.14 times r, which is 2, times height, which is 12. We want to cover this. All right, so let's see. It was half, or 2 times 3.14 times 2 squared plus 2 times 3.14 times 2 times 12 equal 175.84 or divide that by 2 or multiply by a half, we get the same 87.92 square centimeters. And yes, this is easier, but the reason I did it is to show you some scales you could use. You know, you'll find half of the 2, give you 1, pi r squared, find half of this. This basically half cancel 2, which is 1 pi rh. Factor out pi, we have out there, factor out. That's the r outside, and distributive law would tell us that these two should go inside, and then we just substitute afterwards, right? Get 2 plus 12, you get 14 times this product of 6.28 and get the same answer. Okay, good. And then we find, once we found this area, then we find the area of the cuboid. That's the outer portion that's available for us. Okay, 178, 176, and then we work that out. All right, so yes, this video was long, I know, but just really want to show you as much as we can from a visual standpoint, so you can really understand what's happening. For clarity, I'll show you again. When we found the area for this side, multiplied by 2 because this side is also has the same measurement for the same congruent faces. This face is congruent to this. In other words, matching. This face is matching this one. So when you find the area of one, you just multiply by 2 to get the total for both opposite sides. Find the area of this, same as this one, but when it's on top of the cylindrical base prism, you won't be able to. It's not going to be on the surface because it's covering it. You know, so you just work out this side and opposite side, this side and opposite side. You can see, and this side on top, but not this underneath because it was on top of the cylindrical base prism. Okay, so hopefully that was helpful.